And next year, if you take Calc 2, we do what's called logarithmic growth. So something to look forward to later on. But anyway, population growth at least for shorter time periods, okay, usually follows this pattern, okay? It's the population grows at a rate proportional to the size of the population. So this is what I'll do. I'll do this in pink. So population grows at a rate. So how do you make sense of that? That's dp dt. So the rate the population grows with respect to time. So this is like your population growth, okay? Now proportional, I want to use that, I'll do blue for that. Proportional to the size of the population. So for example, like say you've got a bunch of bunnies or you've got your fruit flies. Don't you still do that lab compile? Basically, the more bunnies you have, the more fruit flies, the more people, the more babies there are going to be, right? Like there's the more people that can reproduce, or the more bunnies that are reproducing, the more population's going to grow, okay? So more population, the bigger the growth, okay? So that's why the way they write this formula is the rate is proportional to whatever your population is. So the size, so K, oops, I didn't write that. K is like your scalar. It's like a fancy number that like represents that proportionality. And then what do? I'll do green for P. And P is just regular population, like the actual. Maybe I'll write actual, I don't know. Like the population of the people under ideal conditions for growth. So for this one, this is why I'm saying it's on short term, because we're not dealing with like carrying capacity, stuff like that. You know, like the earth obviously is only so big. We can only have so many people on earth, but like this is like short term, okay? Oh, and then T is time, which we can have. All right, so this is gonna be so exciting because what we're gonna do is we're gonna solve that equation. So we're going to use, just like, you know how you did the bird thing right here, you're going to come up with a general equation for this population growth. So what we're going to do is like, it's almost the formula is too easy, or like too simple, it's hard, you know what I mean? But what you're going to do is you're going to do separable equations, right? So you want to put the P with all the DPs, and then I'm going to try to keep the K with the DT. If you want, you could remember there's always cross multiplying as an option. I don't know if I even still have to do this, but essentially you're kind of doing like a little cross multiplying. So what ends up happening is you get 1 over P dP equals K dt once you separate it all. Oops, let me see that fine. All right. And then what you're going to do is integrate both sides, right? So K remembers like some rando number. We don't know what it is. And then P represents the population. So P is a variable. And then you can tell too in like the Lebanese notation, P and T are your variables. Anything else is like some number. So K is, maybe write that. This is like some number, right? So if you were going to integrate some number, okay, maybe right over here, you get, well, on the left side, that'd be natural log, right, of P, just 1 over P. And then this one, because it's a number, think about it if it was like a 5. You know what I mean? It would just be whatever the number is times T plus C, right? Because you're integrating with respect to time. And then this one, we don't have a C, like they didn't give us like an initial condition or whatever, so we're just going to treat that as another variable. So what I'm going to do is I'm going to solve for P. So I'm going to E it up. So I get absolute value of P equals e to the kt plus c. And then just like the other ones, maybe I'll just show this, why not? Remember, you can do like reverse exponent rules. Do you remember that? And then that e to the c becomes a new and improved c. Yay, okay? Now, because AP is annoying, okay, they like to change sometimes what that variable is. So sometimes they keep it a C, sometimes they like to change it to an A. Maybe I'll just keep it as a C for now, but it would be C e to the kt. So the C, I just changed it into a new and improved. This could be, again, any number, right? So like, this could be any letter. It could be an A I've seen, or a P. They use P a lot as variable. So it's like just another constant, basically. Now, because we're dealing with population growth, we're not going to deal with like a negative population. Like, you can't have like negative people. Plus E is just exponential, like it's just going to keep going up. So that C right there, we're going to assume is always positive. So then the formula, I'm going to write as P of T for the population. And then I think I'll use, I guess I'll just use C. And then e to the kt. So you might notice if you change the C to a P and the K to an R, you now have the PERT formula. Okay, but this is just your generic population growth formula. Yeah.
If they change the letter for C on the exam, will they tell you that they changed it?
No, they'll just tell you it's this.
Oh.
Or you just have to know it's into something. So like A, C, P, whatever the letter they're feeling, which is fun, okay? Keep in mind too, with this formula, this number, if your T equals 0, so say you plug 0 in for T, notice that gives you that value A, right? This is like your initial. So I don't know if you remember from pre-calc with your PERT formula, but P was like your initial population. So this works with like general population growth with like animals, people, whatever. But then also this works with money. So this is big on money. So like you have, the more money you have, the more it's going to grow. So, all right. So now we're going to do some examples. Okay. So this is usually how they ask it. They'll say the population of a country is growing at a rate proportional to its population. If the growth rate per year is 4% of the current population, how long will it take for the population to double? Okay, so what you want to read is it says the population is growing at a rate, okay, what did I use for this? Proportional to its population. So what that means is it's following this, like, this model, okay? So what you can start with is you can be like, oh, this is like a very common population growth. So when it says that in the question, population growing at a rate proportional to its population, okay? That's how you know it's for sure going to be this thing, okay? Now, if you want, you can do the separating of variables. So if you're desperate and you forgot this equation, you can do this full separation of variables every single time for every single type one of these questions. Or you could commit to memory. This is the formula for your population growth. So like I said, if you get desperate on the AP test and you forgot how to solve that equation, you could do separation of variables, do your little cross multiplying thing, integrating, blah, blah, blah. Like basically everything we just did in step 1 or question 1. Or you could just memorize that. I think it's easier to memorize it if I'm being honest. Okay. So now what you're going to do is just fancy plugging in, honestly. So it's basically if the growth rate per year is 4%, how long will it take for the population to double? So this again, P of T is population. So if I want the population to double, that's like whatever my initial is. So say my initial is whatever A. Okay. If I want it to double, that would be 2A, correct? So whatever my population is doubling, if I want it doubled, I do 2A, triple 3A. Okay. So A is your initial, doubling is 2, double it, right? And then they give me the rate per year is 4%. So I'm going to put 0.04 because percent, you got to change it, you know. And then T. Because they said how long will it take. And then now you're just doing your algebra. Well, actually, it's more algebra 2 stuff. So what I would do first is divide out the A's. Right? Because you could just write that as 2. And then you can solve for T. And I've seen this vary. This has been on calculator and no calculator. Usually on multiple choice. I haven't seen one on free response, so maybe this will be the year they decide to throw us. But otherwise, now we're just solving for your T. So you're taking natural log of both sides. Let's get natural log of 2 is 0.04 T. So like if it was a multiple choice test, and there was no calculator, they would write it like this. Maybe they'll mess around with that fraction, maybe not. But that would be like the answer as far as like no calculator concerned. Otherwise, you would just tip tap around that guy and you'd get 17.329 years. So K is like the rate per year. And then the doubling or tripling or half or whatever you need is going to be like messing around with A. Yeah?
Where does the doubling rate come from? Like the equation we're given is 70 over rate. Where does that equation come from?
Wait, can you say it again?
You can find doubling time by using 70 over the rate, but I don't know where that equation comes from. 70 over 4 is 17 and a half. So we use it for apes and that AP geography, I remember.
Yeah.
Doubling time. Is that
I think that comes from this stuff. I don't know. I'd have to sit down with it first. But that's cool.
just wondering,
Yeah, it comes from calculus, I'm sure.
Yeah, okay.
So.
We use the other rates. It's just 70 over the rate, 70 over 4 is 70.
Okay. Here's another way to ask directly proportional. If it says the bacteria is increasing continuously, okay? That's another way to be like, oh, I'm using the quote-unquote PERT formula. The rate proportional, again, that's that K to the number present. Again, so very similar language, but now instead of saying growing at a rate, they say increase continuously. That's like the same idea, okay? So different way to ask it, but the same vibe. I'm going to change the variables though, just because I'm going to do, I don't know, just because I can, I don't know. I'm going to do the bacteria over time is equal to a rate proportional, so there's K, to the total present, B, the total amount of bacteria present. I'm changing the variables because just like the baby bird problem, they'll change the variables on you too. So as long as you're kind of like get the same vibe, it's still the same thing. Instead of B, I'm doing P. Or instead of P, I'm doing B. Okay. So for this first one, again, I'm going to be like, dot, 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 I know things. I can be like, well, B of T is just A, E to the KT. Like that's the same formula that we've been using. I don't need to do separation of variables because I'm a boss and I remember everything. Okay, so anyway, if the number triples in 6 hours, how many will there be in 12 hours? Okay, so where they actually give us like two kind of tidbits of information because they're talking about tripling. So remember the last one was doubling. I'm going to do 3A. And then they said in 6 hours. So really what I'm going to be solving for is K. I just start plugging stuff in and hopefully it works out with all of these. And then now you're going to divide out the A and kind of do the same thing. I like when it's 6K. That makes me looks cuter that way. So now what I'm going to do is natural log it. Take the natural log of both sides and divide by 6. Let's keep it over here. So natural log 3 divided by 6. Is everyone still alive? Okay. So that's the K value, and it says how many will there be in 12 hours? So I guess I solved for K. I just kind of went with it. I didn't really like have an end plan. I just hoped it worked out. And then now I need a total population. So it seems like the bacteria is what I don't know. And the A, it's like, wait a second. They didn't give me an A, did they? No? Okay, so we'll just put A there. This is seriously what I do. Like, I'm just kind of like rolling with it, trying to plug in anything I can. And then E to the K, K I actually know. That's that goofy thing. Natural log 3 over 6. And then 12, apparently. Oh, because I did it with hours to start with, and it's still hours with both of them, so I don't need to. Because I solve for K using hour unit, so I don't need to worry about it. That would be mean though, wouldn't it? If they changed it? That would be. Okay, so now I'm just gonna clean this up apparently, and we're just gonna kind of vibe. Okay, what is this? 2 natural log 3, right? Because 12 times 6, or 1/6, right? So there's a 2 left. Okay, what am I supposed to do with this? Well, because of that, the 2's kind of throwing my vibe off, because if the 2 wasn't there, I could like those would undo each other, the natural log and the E. So I'm going to do some snazzy stuff here. Ready? I'm going to write this as 3 squared. What? See what I did there? I put the 2 that was in front and did a little log rule. So, again, A's just hanging. We're just going with it. This would be E to the natural log of 9. Right? So then that ends up being 9A. And then this is all I could go to. So then I read the question, and it says, how many will there be in 12 hours? Well, A's like the initial, so I would just say 9 times, right? Times the size. So it tripled in 6 hours, but if in 12 hours, it would be 9 times the size. Woo! Bacteria growth, that's kind of disgusting. Okay. And again, usually this is multiple choice. So like you'll see the options and you'll see like 5 times the size, 6 times the size, 9 times the size, all of that written in there. Okay. All right, part B. How many hours were the original number quadruple? Okay, so they want the triple and the 9 times, but now they want quadruple. Okay, so you're gonna solve it the same way as this other one, that doubling one. So I want quadruple, so that's 4. E, and then I need K. Just kidding, I have K. Because I'm dealing with the same stuff. So K is this goofball thing. Natural log 3/6. That's a normal number. Okay, times time. Do I have a time? No, I don't have a time. That's what I'm solving for. Yeah.
So the K, even though the K was meant for the tripling, doesn't matter?
No, because it's all works together. So the K is a constant that you solved with the other problem. So the K doesn't change.
So what if it was like, what if it's like, if the number doubles in 6 hours, then that K would...
Then if it was doubling, it would be a different K value.
Okay.
Because they told me it triples in 6. So I have to go with the tripling idea. And and then that K is consistent with everything else. Because I used it, because K doesn't change with the different problem. That's a good question. Because now we're just mathing, right? So you're doing take natural log of both sides, right? Divide it out. Again, if it was no calculator, they give you this as an option. Or if it was calculator, they make you tap it out on the calculator. So in 7.571 hours, that's how long it would take to quadruple. So, do you guys still do that fruit fly lab in AP Bio or no? No? No.
I don't think we can set it up as 4. Maybe set it up with the A.
Because this is the initial, you know, and they didn't actually tell me what it was. So say the initial was 1, to quadruple it, it would be 4. So I usually just kind of think of A as 1 just to be easy, or think of dividing A. Yeah. Yep. Yep. Half-life. We don't need to do that. Let's do this one. Okay, so say we have a rate of 5% compounded continuously. How long does it take to the nearest year for an investment to triple? Okay. So again, this compound continuously is another keyword for PERT. Okay. So think of it as like the population of your money. Does that make any sense? Like your total money. So like your total money is continuously increasing, right? So that's like your KP, and again, because I'm cool, I just remember the formula. P of T equals AE to the KT, right? So now what I'm going to do is I need to figure out for the tripling. So it's like the same deal, like you're tripling. So I need 3 times the initial E, and then the K was 5%, so 0.05 times time, and then you algebra it out. T. So I divided out the A's, natural log it, all that jazz. Divide out the 0.05. Again, if it was multiple choice, no calculator, they'd leave it. Ooh, excuse me. And since I have such good math skills, it was 21.972, but they said to the nearest year, so 22 years. Invest your money early, everyone. I think because my husband and I are math teachers, we're like psycho with saving because we know how far our money goes if we invest it now. Because I'm a PERT follower. So we need to remember to enjoy life instead of just put all our money in our stock portfolio because it just grows so much faster when you do it early. So anyway, fun fact, life hack, open a 403B the second you can. Okay, anyway. All right, this one is when they do weird stuff at you. So notice they say inversely proportional, okay? These are actually really easy, honestly, but people overthink it. So you gotta settle down, okay, when you look at these. So when it says the rate of change of Q with respect to T, rate, derivative. So derivative of Q with respect to T. Okay, got it? Actually I can even do it further. Is equals, in math lingo, inversely proportional. Okay, so this is where things get weird, okay? Here's the deal. This proportional is code word for K, okay? So K is always on the numerator. K is always just K. K times, but the fact that it says inversely proportional to the square of T, you gotta put K on the numerator and then the square of T, T squared on the denominator. So if it's straight up proportional, it would be K times T squared. Since it said inversely proportional, you have to divide. Okay. And then what do they want? Oh, they want me to solve it? Gah. I guess that's fine. Whatever. Actually, I might just keep the K over there. It's going to be a little wild today. Because then Q's by itself. Do you know what I'm saying? It's really nice. Okay, so I'm going to keep the K with all the T junk. And then I'm going to integrate it so I get Q equals... Wait. Okay, so T's the variable because it's dt. You know what I mean? So what would that be? Oh, it's T on the denominator. Dang it. So that's like T to the negative 2, right? So that'd be negative K over T. And then plus C, whatever it is. And there it is. It's like no numbers. That's how you know it's a good one. So, yeah. Okay, this one. Rate of change N with respect to S. S, what are we doing with S? Whatever, you just go with it. Rate of change of N with respect to S. DS, gross. It's fine. Is, oops, poor is didn't have its moment. Equals. Proportional, see the word proportional, write a K. Doesn't matter what comes after, just put a K, right? It's proportional to... Oh, so it's not even inverse. It's just regular, you know. So you're just going to multiply by 250 minus S. I hate S's. They look like 5s. It's okay. All right. Everyone okay? And then you solve it. This isn't PERT because 250, or like you should have a N there. You know what I mean? This is in PERT formula because otherwise this green part has to be N. Okay, it doesn't follow the same form. Same with the T squared thing. We weren't squaring stuff with PERT. You know what I mean? PERT was always this KB thing, right? It was always whatever your population is. Same with this one. This was KP for money. okay? Whereas these ones are weird. So don't do PERT stuff for this. This is like the normal ones that you're solving for. So as far as integrating, I guess I'll keep dn by itself because you can. And then this would be what? K. Actually, this is actually not that bad. ds. Hopefully. I don't like that k over there. It's freaking me out. K is a number. Actually, I can integrate dn. It's just n, so that was easy. I'm going to keep k out there. Don't judge. I need to show it. Makes me feel better. Because then I don't worry about it. I'm like, I'm just going to tack k on, you know, like later on at the end. Because k is just some rando number. It's kind of like if you were to integrate like 6 sine x or something. You know, like technically you could just do sine x and then tack the 6 on later. Do you know what I'm saying? So I'm just keeping the constant off to the side. And then now I'm going to integrate this, which we would get k times, and then if I integrate it, wouldn't that just be 250s, I hate s, minus 1/2 s squared, and then plus c. I'll call it. That'd be good. It's a bad circle. Okay. That's it.